Most AI workflows break the moment they hit real-world complexity. Prompt chaining doesn't scale. Stop settling for rigid sequences. Start building systems that actually reason. Today we architect a multi-agent hierarchy in Azure AI Foundry Agent Service. This is for engineers building beyond single prompt apps. Foundry threads persist state server-side, so agents resume without resending full context. We cover three things: tool calling, stateful handoffs, and session persistence. One of them hides a gotcha that silently drops your context. Watch for it near the end. Here's the blueprint. An orchestrator agent owns the conversation and the plan. It delegates to specialized sub-agents through connected agents. One researcher pulls live data with tools. One analyst reasons over results. The orchestrator never does the work itself. It routes, collects, and decides the next handoff. Each agent runs on its own model and instructions. This decoupling separates reasoning from execution. That's the whole point. Agents are useless without grounding in real data. Tool calling fixes that. You register functions or built-in tools on an agent definition. The model decides when to call them and with what arguments. Foundry runs the call, captures the output, and feeds it back. Use the grounding with Bing tool for live web facts. Use Azure AI Search for your private knowledge. Define a Python function for anything custom, like an internal API. The agent picks the right tool per turn. No hard-coded sequence required. Now the handoff logic in Python. Create each specialist as its own agent. Then wrap a sub-agent as a connected agent tool. Attach that to the orchestrator. When the orchestrator needs research, it calls the connected agent by name. Foundry routes the request, runs the sub-agent, and returns its answer. The orchestrator stays in control of the flow. This is declarative. You describe who can delegate to whom, not a fixed call order. Here's the gotcha I promised. State lives in a thread, not in your code. A thread holds the ordered message history server-side. Every run appends to the same thread, so context survives multi-turn loops. The mistake people make is creating a new thread per turn. Do that and the agent forgets everything instantly. Reuse one thread ID across the whole session. Sub-agent calls don't pollute the parent thread. Their internal reasoning stays scoped. Persist that thread ID in your own store to resume later. Now the real architectural decision. Centralized control versus distributed autonomy. A single orchestrator gives you predictable routing and easier debugging. You see every handoff in one place. But it's a bottleneck and a single point of failure. Distributed autonomy lets agents hand off to each other directly. That scales reasoning and handles open-ended tasks. The cost is unpredictable paths and harder tracing. My rule of thumb. Start centralized. Loosen control only when one orchestrator becomes the bottleneck. How do you know it's actually working? Inspect the thread messages after a run. You should see the orchestrator's tool calls and each sub-agent reply. Check run steps to confirm which connected agent fired. Watch latency. Every handoff adds a model round trip, so deep chains get slow. Trace token usage per agent to catch runaway loops. Set a max turn limit as a guardrail. If context survives a second user turn, persistence is correct. Let's lock it in. Tool calling grounds agents in real-time data. Connected agents give you stateful handoffs without hard-coded sequences. Threads hold session state server-side, so reuse one per session. And choose centralized control first, autonomy only when you need scale. Pricing and API surfaces change fast, so check the current Azure AI Foundry docs before you ship. Build the orchestrator today and watch your thread messages flow. If this helped, do me a favor, hit the like button, subscribe, and tap the bell so you don't miss the next one. See you in the next video.